All right, good morning. I want to start with sort of asking you to think how you got here, because the way how I got here was pretty disturbed by a storm on the East Coast. So I was trying to get here on Sunday, and then it was a mess on all the airports, and people were flustered. I was flustered. An equally flustered person bumped into me. I dropped my passport. I bent over to get it. I dropped my water bottle. And after I captured this, my phone fell down. And so I went downhill from there. I'm just saying this to emphasize the trickle-down effects and the flusteredness. And that's the same case for our ecosystem in the critical zone. That critical zone is flustered, to say the least. And kind of this idea of recovering from things when things become disturbed, that's the concept of multidimensional resilience. Real quick, the definition for the critical zone. So this is the system spanning from the treetop all the way down to the actively cycled groundwater. That's a highly interconnected system. And we have a lot of disturbances that impact this critical zone, right? That's ranging from drought over wildfire, precipitation, acid deposition, coastal flooding, land use change, land cover change. I'll comment on the last two. And that impacts ecosystem or critical zone services really strongly. And they're important. They're more important than me catching my flight. They mean life on Earth is possible. It's really important. So I want to shout out real quick, I'll give a shout out to these people here. This is a group that came together last summer at an all-hands meeting. It's from the Critical Zone Collaborative Network, which is a group of projects that was funded in 2020. And we were at this all-hands meeting and thinking about how can we work on synthesis around this idea of disturbance, critical zone resilience. And so we did. I want to, though, explain a bit this multidimensional piece. So this is a fairly typical representation of what can happen if you have disturbance. So here on the x-axis, the disturbance increases. This is a response surface. If this ball is sort of having a hard time moving away when you increase the disturbances, that's a pretty resistant system. So that would have happened if I don't drop my passport. Or if a system can really bounce back after a disturbance really quickly, which is here on that example, that's really easy for recovery. Together, that means that's a resilient system. So you can think of it, all these types of ecosystem services, and these are just some examples. And because the critical zone is such an interconnected system, the response to disturbances should be highly interconnected as well. So when we're looking at this from the bird's eye perspective, we didn't get to play with visuals in all crazy ways. Okay? So this is a way for us to visualize how these pieces are actually connected. Okay. So this here is an example of the types of locations where we have research that collects data that's able to diagnose the critical zone really from the top of the tree canopy all the way to the actively cycled groundwater. So there's a lot, and this is just an example. There's more sites even than this. So they span across the entire US, and this is a US-focused map because that's where I tend to do my research right now. But these sites also exist across the globe, by the way. These are the sites where we're like, yeah, we want to actually look at a couple of examples and synthesize this. And these are the sites that I have time for today. So I'm just going to give you a couple of examples. The first one comes from here, from the Calhoun Critical Zone Observatory. And I've seen that in this session, there's a lot about soil moisture. There's a lot about roots. So this is really important. And the disturbance really is land use change from old growth to row crops. And what's really important here is that we have much deeper and more roots in the old growth, which means that when you're looking at the age of CO2 that's really drawn down, that is coming from photosynthate, it is much older and much younger and much more in the old growth forest. So we have fresher, deep carbon if we keep the old growth. That is important carbon sequestration. So in the context of this multidimensional resilience, and here shout out to Dan Richter, these are some really deep soils. The carbon sequestration goes, it impacts biodiversity. It also impacts, of course, I don't have to tell this to the soil moisture people, the water quantity. And then what are the impacts of this? We don't know. There is a lot more. The next example is also a land use change from the drylands, critical from the drylands cluster. So here we're going in a land use change from natural drylands to flood irrigation. And the interesting piece here is that this is not only the land use change, this is superimposed by climate change because the irrigation waters lose their water quality too, because they're becoming more saline. So what's happening is that we're seeing a lot of high salinity waters, lots of pedogenic carbonates in the soil. So in that context, water quantity goes. That impacts water quality. It impacts soil services, for sure agricultural production, which is the livelihood of the farmers in that region. Kind of like putting in a little bit of a good thing here. The dryland cluster is investigating how can be a more surgical approach to getting water to a plant help in this context. So drip irrigation using salt-tolerant crops, for example, might just move the dial on a couple of those. The last example is coming from the coastal cluster, and this is sea level rise and storm surge and intensification. We always had these storm surges here, and plants typically, they come under, we're like in these salinity ranges that introduce plant stress, but this is typically, or used to be short-lived. Now, superimposing climate change and sea level rise onto this, we're probably constantly in that window that brings us into the plant stress. So that means forest retreat, that means crop failure. And when the water quantity changes, vegetation health changes, biodiversity and habitat is impacted. In that case, of course, the agricultural production is impacted. However, drizzling in something good. This also means marsh migration, okay? And that brings us back to carbon sequestration that has an important effect. So we produce more questions than answers. This is more like a pinball kind of thing, which I think is okay because we can use these conceptual models thinking about what are the trickle-down effects, how can we learn from each other, and how can we use data-based approaches to vice versa with these pieces. Okay, I'm in the red here. Last piece, this is a map, the next steps on showing how does this impact already overburdened communities that are impacted especially by climate and economic injustices. And with this, thanks so much for your attention.